Terrifying Auroras, presented by Science at NASA. Last month, a cloud of plasma from the Sun hit Earth's magnetic field and sent northern lights spilling across the Canadian border. In the United States, stunned onlookers saw blood-red auroras as far south as Alabama, Georgia, and Texas. For many skywatchers, it was a once-in-a-lifetime event. On the planet called Kourou 2b, it could happen almost every night. Located about 880 light-years from Earth, the gas giant is routinely blasted with X-ray solar flares 100,000 times stronger than anything we experience on Earth. Moreover, the battered planet orbits its star 97% closer than Earth orbits the Sun. When it gets hit by clouds of plasma, or coronal mass ejections, at such close range, the results could be as beautiful as they are terrifying. Kourou 2b probably has auroras visible at all latitudes, even in the planet's deep south, says Scott Wolk of the Smithsonian Astrophysical Observatory at Harvard. Wolk simulates what systems like these could experience using data from NASA's Chandra X-ray Observatory. The lights would be beautiful to see, he speculates. That is, for the few seconds a human could survive there. Solar flares from the parent star are so powerful, they actually blast away some of the planet's atmosphere. About 5 million tons of matter every second, Wolk says. This could endow Kourou 2b with a long comet-like tail whipping through the auroral glow. No one knows for sure, however, because the planet is so far away. Despite its tremendous mass loss, the planet is in no immediate danger of evaporating. Kourou 2b is losing about 150 million billion kilograms per year. That sounds like a lot, but it is just a drop in the bucket to a planet more massive than Jupiter. It could sustain such erosion for thousands of billions of years. Kourou 2b gets its strange name from the spacecraft that found it, the French Space Agency's Convection, Rotation, and Planetary Transit Satellite, Kourou for short. A group of astronomers led by Sebastian Schroeder of the University of Hamburg in Germany recently conducted a detailed study of the Kourou system using Chandra and the European Southern Observatory's Very Large Telescope. The results suggest that Kourou 2b has a hand in some of its own troubles. The planet, in part, causes the flares. Wolk explains. Kourou 2b orbits at breakneck speed, making a complete circuit around its parent star in only 1.7 days. Because the planet and star are linked by strong tidal forces, the headlong rush of the planet speeds up the star, causing it to rotate faster than it otherwise would. The spinning of plasma inside a rapidly rotating star creates a more active magnetic dynamo, which in turn gives rise to the magnetic fields that create sunspots and flares. By spinning up the star, Kourou 2b sets the stage for flares in general, but it doesn't stop there. By rapidly plowing through the star's magnetic field, Kourou 2b probably sets off specific magnetic instabilities that cause flares as the planet passes by. Kourou 2b is literally sealing its own fate. Maybe living in a place where auroras are mostly confined to the poles isn't such a bad thing after all. For more information about planets, beautiful and terrifying, visit science.nasa.gov.